A pleasant greeting on myself, P. Parthiban, and I was pursuing third year B in mechanical engineering at Coimbatore Institute of Technology, which is located at Coimbatore. And today we are going to on discuss on the topic which is on merchant cycle diagram. It is coming under the subject which is manufacturing process in mechanical engineering. First of all, let us see what are the various forces which is involved in machining process. And at first, we are going to see about the two basic forces, which is a cutting force and a tangential force. And a cutting force, which is mentioned in this diagram, which is an FC, and tangential force, which is FT. These forces are measured with the help of the force sensors in a machining process. And you can see it is in a tool, which is on the tool parallel force, which is on a cutting force, and which is perpendicular to the tool. It is an tangential force. And this green line, which is represent the resultant, which connects the cutting force and tangential force, and it makes an closed system. It's like an triangle. Next, which is going to say about next, which is on a frictional force and on a normal force. It is on a rack angle. It is on a tool rack angle. From the extensions of the tool rack angle, it will be come down. So it will be considered as an friction force, which is FF, and which is a N. Here represent the N. It is a normal force which connects the resultant and the friction force. And next, we are going to see about an shear force. And a shear force which can be obtained by using some of the formulas, one of the formulas, so we can get it. And here it is mentioned, it as an Fn, it is a normal shear force. Next, you can see the previous three slides, which consist of different forces in the combination of the six forces in one diagram. You can see it here. First of all, we see about a cutting force, and it is the parallel line, which is on a cutting force, and perpendicular line, which is on a tangential force. And third one is a resultant, which connects the cutting and tangential. And the fourth one, which is a frictional force, and which connects the tangential and frictional by the force, which is a normal force. And you can see how which is an shear plane, and Fs, which tells an shear force, and the Fn, which from this line, which is connected, it is a normal shear force. And you can see it is in the notations, it's theta, and it's in a tool rack angle. It is in shear angle, and it is in a tool rack angle. Next, and you can see here, these are the formulas which is helps to get an angle in that diagram, which is tan theta is equal to RC cos R by 1 minus RC sin R, where the cutting ratio, this is a formula. To obtain the RC, we will be using this formula, which is an RC is equal to cutting ratio. And for an these are the forces for an difference for which is normal and shear force, and then so the normal shear force we can get it by it. Next, the coefficient of friction. These are the formulas for the coefficient of friction and then a friction angle. You can see here, this is an friction angle, and it can be obtained by the friction angle is equal to tan inverse of the coefficient of friction. Next, this is on a main topic, which is an merchant cycle diagram. It is also known as a MCD, which is mainly which is helps to use to calculate the forces in machining. It is one of the graphical method to calculate the forces in machining. It is calculated from the form of measured forces. Okay, next let's get into a topic which is on how to draw on a merchant cycle diagram. First, it is like it looks like a graph to for an easy understanding. You can see here it is a tool, and which is this is a tool rack angle. First, we already saw it is in a force which is parallel to the tool, and this is a tangential force. And you can see here from this line it has been moved to that line, and this is an R, which is a resultant force, cutting force, and which is connect the cutting force and the tangential force, which is a resultant. And from the resultant midline we draw on a circle, which represents it is an a merchant circle. From next, from the tool track angle, there will be extensions. You can see it will be moving from top to bottom. So it will be extended till the tip of the merchant cycle, uh, which tells an FF. And you can see it is a normal force. Next, we will be moving to shear angle. So we will be drawing an horizontal line which is parallel to the cutting force, and we will be obtaining the shear plane, which is by the formula consideration. And you can see these shear force will be getted through the formula. This from the tool tip to the merchant cycle tip, and from that it will be extended to the tip of the resultant. So we get an shear angle, and it is an shear angle. We can get it, which is a tool track angle. And you can see that I said that the shear plane angle, which is determined by motion, yeah, the shear plane angle will be determined with the help of formula. So we get it here, which is an shear plane angle, and it is an rack angle. I said it already, which is the tool rack angle, and this is an friction angle. This is an friction angle, and it's denoted by a symbol. Next, the total, it will be little confusable, but it will be cleared. It will be make it in one diagram. You can see it was in a tool, and it was in machining. There is a chip formation. You can see it. The FZ, it is in a cutting. These are the difference causes which is mentioned in a merchant cycle diagram. You can see which is F is an results, and N for normal, and P for friction force, Fn for normal shear force, stress force, Fx, and Fs it is an cutting force. Alpha, which is you can see here, which is represent the rack angle of a tool, and beta, which is represent the shear angle. You can see it here. It can be obtained by a formula, and this is a friction angle, which is between the resultant and the normal force, which is a friction angle. Next, let us see some of the advantages of a merchant cycle angle. It is very easy and quickly, and it is reasonably accurately determination the forces and machining, and the friction at the tip tool interface and the dynamic yield shear strength can be easily determined, and equation relating the different forces are easily developed, and these are the major advantages of advantageous use of the merchant cycle angle. And there will be, when there is an as usual advantages, there is some of the disadvantages. So the various disadvantages are which is the MCD, which is a merchant cycle diagram, is only valid for an orthogonal cutting, and it is working based on the single shear plane theory. And the final one is by the ratio of Fn, the merchant cycle diagram give an apparent, not actual coefficient of friction. And on this basic topic, there is a video references. It has been attached here. You can see it here. And that's it about on the topic of merchant cycle diagram. And thanks for the opportunity given to me. And thank you once again.